Today we're taking a look at section 11.5 on counting problems involving not and or. And what we look at first is what's called the complements principle of counting. It says if A is any set within the universal set U, then the number in A is equal to the number in U minus the number in the complement of A. Likewise, we could also say the number in the complement of A is equal to the number in the universal set minus the number in A. So we could also write the equation that way. So if we're talking about a deck of cards, 52 cards, and let's say we want to know the number that are not hearts. What we can do is we can take the number in the universal set, which is the 52, minus the number of hearts, which is 13, to get the number that are not hearts, which would be 39. So that's basically what we're talking about here with the complements principle of counting. Okay, another example. If we have 4 fair coins that are tossed, in how many ways can you get at least one heads? The only exception to at least one's heads is having no heads or all tails. So let's begin with the total number of possible outcomes when tossing 4 fair coins. So here's coin 1, here's coin 2, 2 possible outcomes, coin 3, 2 possible outcomes for coin 4. So there are 16 possible outcomes for tossing the 4 coins. Now, there's only one way to get no heads or all tails. There's only one way to get that. So we take our 16 minus the 1. That means there are 15 ways to get at least one heads. And this is a very common way to get the, let me see if I can get the highlighter here. When we're talking about at least one, is to take 1, the total number minus the 1, which would be the one exception. Okay, so, and you can do it for at least 2 by using 2 exceptions, 0 and 1. So, and now let's, some of this comes from 151. Let me go back to my regular pen. How many subsets does the set 1, 2, 3 have? Okay, if you'll remember, we count the number of elements in the set and we raise 2 to that power. So there are 8 subsets. How many proper subsets does the above set have? If you remember, proper subsets are all the subsets except the set itself. So that's going to be 8 minus 1. And the formula for the number of subsets is 2 to the n, where n is the number of elements. Elements in the set. And then the number of proper subsets. Whoops, I don't want to put it like that. Let me get my eraser. Eraser, I forgot to pick the size. Eraser, small is fine. I want to be careful not to do what I just did. Okay, we want to subtract the 1 from the 2 to the n. And if you want to review this, this is back in chapter 2 under the section on subsets. So you can see we've carried over some material from that. Alright, the general additive counting principle. If A and B are any 2 sets, disjoint or not, then the number of elements in A union B equals the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. And so if we have A and B here, and we want to talk about the number of elements in the union of A and B. We can see it's 16 just by looking at the picture. Notice if we look at the number of elements in A, it's 6. If we look at the number of elements in B, it's 11 because it includes the 1. We double counted the 1, first in A and then in B, so that's the number of elements in A intersect B. And because they were double counted, we need to subtract those. So we get 17 minus 1 is 16. Okay, and this plays a role when we're counting in an OR situation, and that's what we're going to look at in the next example. It says, if a single card is drawn from a regular deck of 52 cards, in how many ways can you get an ace or a diamond? So we want to add the number of aces plus the number of diamonds minus the number of aces that are diamonds. So number of aces is 4, number of diamonds is 13. We have one ace of diamonds, so we have 17 minus 1. There are 16 ways to get an ace or a diamond. Okay, so let's see if we can do the next one. This one I'm going to let you try to do. If one card is drawn from a standard deck of 52 cards, how many ways could you get a club or a face card? So you want to count the number of ways to get a club, the number of ways to get a face card, and then subtract off the number of ways to get a club that is a face card. So see if you can figure out the answer to that question. Just pause the recording until you have an answer, and then restart the recording to check your answer. Okay, I'm assuming you have come up with an answer. There are 13 clubs and there are 12 face cards. So the number of clubs plus the number of face cards, and then we want to subtract off the ones we double counted. So we double counted the club face cards, and there's a jack, queen, and a king, so there are 3 of those that we double counted. So hopefully you got the answer 22. Hopefully you got the answer 22. Okay, your next step should be to watch the online sample problems, the recorded sample problems, and so that's where you should go next.